Okay, this is exercise 195 on page 403, which is more examples with algebra and whether or not the function is continuous. So here's the function f of x equals 2x plus 3 divided by x minus 2. Is it continuous? You have to do two things. You have to calculate f of 1, right, at x equals 1. And then you have to do the limit as x goes to 1 of f of x. All right, and so let's take a look at these two things. So f of 1 is a just plug in, 2 times 1 plus 3 divided by 1 minus 2. Perfectly valid thing. 2 plus 3 divided by 1 minus 2, 5 divided by 1. No, 5 divided by negative 1, so negative 5. Okay, what about the limit? Let's do the limit now. And for the limit, we can use our limit laws. The limit laws say we can do the limit of the top divided by the limit of the bottom, 2x plus 3 divided by the limit x goes to 1 of x minus 2. On the top is the polynomial, 2x plus 3, so we can just plug in on the top, and we get 2 times 1 plus 3. On the bottom is also a polynomial, x minus 2, so we get 1 minus 2. So we can just plug in. That's great. And we have the exact same calculation we had before, same number, minus 5. Since the limit equals the value of the function, therefore, yes, continuous. Yes, continuous. Okay, let's do part B now. And in part B, very different story. I mean, okay, it's the same story. You got to calculate the value of the function and the limit of f of x. Here's the thing. F of 2 does not exist. It does not exist. Why does it not exist? Because you would be dividing by 0. So this would be 2 times 2 plus 3 divided by 2 minus 2. Dividing by 0 is not allowed. This does not exist. So the function is not even defined at x equals 2. Already we know it's not continuous. That's already enough to say it's not continuous. But let's just, for fun, let's keep going and calculate the limit as well. And the limit is the limit as x goes to 2 of 2x plus 3 divided by x minus 2. And on top, we would have, if the limit laws apply, so maybe we should be careful here, if the limit laws apply, we would have the limit of 2x plus 3 divided by the limit of x minus 2. But now the bottom is 0, right? Just like before, the limit of x minus 2 as x goes to 2, just like the 2 minus 2 here is 0. So the limit laws do not apply, and we can't actually do this division. So instead what we can say, so this is not right, don't do this. Instead, we can say, I can tell you what this limit is doing. It's going to be does not exist, does not exist. And why is it going to be does not exist? Because you're dividing by 0. This goes to 0. And this, the top, this is the important part, this one goes to non-zero. So we have a non-zero number divided by something that's getting closer and closer to 0 that is going to blow up, and it's either going to be plus infinity or minus infinity depending on which side we come at it. So it doesn't exist, the limit doesn't exist, and the function's not even defined there. Everything doesn't exist. This thing is super not continuous if you want, not continuous. Okay, at x equals 2. At x equals 2. I guess in the first one I should have said at x equals 1, it is continuous. Okay, I'm going to stop there.